Why would we want a histogram? Well, when we look at a histogram for our data set, one of the big questions that we want to ask ourselves is, what is the shape of this distribution? There are several basic shapes that we want to learn to recognize. Here are the basic shapes we're going to be focused on this semester. We have bell-shaped, uniform, right-skewed, and left-skewed. Our first two shapes here are what's called symmetric. And what that means is, if we pick them up and flip them over left to right, they look the same. In a bell-shaped distribution, our graph is high in the middle and low at the ends. It's going to turn out that we like bell-shaped data because if the data from our sample shows a bell-shaped distribution, there's a good chance that the underlying population has a very nice distribution that makes the math easy. Contrast that bell-shaped distribution with a uniform distribution where the bars are all about the same height. In a bell-shaped distribution, the most common values are clustered together in the middle. In a uniform distribution, the values are kind of spread evenly over the range in which they appear. We also have two shapes that are not symmetric. And when we're looking at shapes that are not symmetric, the biggest thing we're going to look at is which direction they're skewed. We say that our distribution is right skewed if we have a long tail to the right. And we say that our distribution is left skewed if we have a long tail to the left. So the direction of the skew, you can imagine you take a bell-shaped distribution and you grab one end and you pull it out, you stretch it out, and you get a distribution that's skewed in the direction that you stretched it, in the direction that you pulled out the tail. There are a couple of other things we're going to talk about when we talk about the shape of a distribution. One thing we'll want to look at is how many peaks it has. We call that modal. A unimodal distribution has one peak. A bimodal distribution has two peaks. We could have a trimodal distribution, but typically if we have more than two peaks, either that's actually not interesting information or there's something weird going on with the underlying data set. So really, unimodal and bimodal are the things that we're actually going to concern ourselves with, and that only a little. We might notice a repetitive pattern, we might notice how spread out the data are, but the last thing we're going to really pay attention to are gaps between bars. So in the examples that we've already seen, there was a gap. And when we see a gap in a histogram, we're going to want to call attention to it. So here are some examples of graphs and how we would describe them. This first graph here, we would say is roughly symmetric. If we flip it over, it's not going to be perfectly the same, but it's going to be close enough. We would also say that this one is bell-shaped. This next graph, we would say is skewed right. You can see the long tail going off to the right. We would say that this one is skewed left, long tail going off to the left. And we would say that this one is skewed left with a gap. This next one, notice the two peaks. We say that this is bimodal. And if we flip it horizontally, it looks about the same. So we would say that this is symmetric. And then this last graph, notice the bars all have the same height. We would say that this is uniform. So those are just some of the ways that we can describe graphs. In the next video, we're going to go through a data set and make a histogram. and then we'll describe the shape of that histogram.